Welcome back. In this video, we'll be solving problems related to the equilibrium constant. Let's recall the steps that we discussed. This will make it easier for us to understand these problems. First, we must write the expression for equilibrium constant. Next, we must insert the given values in the Kc expression and solve. Now, let's look at the first problem. In our first problem, hydrogen reacts with iodine at 25 degrees Celsius to form hydrogen iodide by a reversible reaction. Here is the chemical equation with all the relevant information, including the equilibrium concentrations. Let's begin by collecting the data first. In this equation, we have the concentrations of hydrogen, 0.05 mole per decimeter cube. The concentrations of iodine, 0.06 mole per decimeter cube. And the concentrations of hydrogen iodide, 0.49 mole per decimeter cube. These are all at equilibrium, and we are required to find out the equilibrium constant. So first, we'll write the equilibrium expression. The equilibrium constant expression is written like this equation. Kc is equivalent to the concentrations of hydrogen iodide raised to the power 2 divided by the product of concentrations of hydrogen and iodine raised to the power 1. Let's insert the given equilibrium concentrations. So, by inserting the values, Kc is equal to the square of 0.49 divided by the product of 0.05 and 0.06. So, the square of 0.49 is 0.2401. 0.05 multiplied by 0.06 is 0.003. By dividing this, we get the answer 80. Therefore, the equilibrium constant is 80. Wasn't that simple? Please note that there are no units since the number of moles of the reactants and products is the same in the reaction. Let's move on to our second problem. For the formation of ammonia by Haber's process, hydrogen and nitrogen react at 500 degrees Celsius as 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. We are given the concentrations of gases and are asked to find the value of Kc. We'll first collect the given data. We observe the concentration of nitrogen, that is 0.602 mole per decimeter cube. Concentration of hydrogen, that is 0.420 mole per decimeter cube, and the concentration of ammonia, that is 0.113 mole per decimeter cube. All are at equilibrium. Let's start by writing the Kc expression. For this reaction, Kc is equal to the concentration of ammonia raised to the power 2 divided by the product of concentration of nitrogen and the concentration of hydrogen raised to the power 3. Once we insert the relevant values, we should be able to solve for Kc. As you can see, Kc is equal to the square of 0.113 divided by the product of 0.602 and the cube of 0.420. Once we solve this, we should get the answer 0.286 mole squared per decimeter raised to the power 6. This is your equilibrium constant. Have a look at the unit, as in this case we do have a unit, as there is an unequal number of moles on the reactant and product side. So that is all for this video. I hope you found it simple and easy to understand. I'll see you in the next video.